Good evening to all the construction professionals who have logged in, and very warm good evening to you, sir. So we have Dr. K.BALASUBRAMANIAM, who has consented to speak on concrete quality and site-related issues. Dr. Balasubramanian took his BE Civil Engineering and ME in Structural Engineering from the College of Engineering, Guindy. He joined Structural Engineering Research Center, CSIR, SERC, Chennai in 1983 as a scientist. Then he rose to the position of Deputy Director. Thereafter, he joined CCL, and he was there for a period of 2 years. At present, he is the Managing Director of High Tech Concrete Solutions, Chennai. It is an NABL accredited laboratory. He also heads an IIT Madras incubated company, Concrete Quality Concepts Private Limited, along with Dr. Manu Santanam, Professor IIT Madras. He is also the Vice President of the International Center for Fiber Reinforced Concrete Composites. So Dr. Balasubramaniam has also served as a member of various committees of the Bureau of Indian Standards. His area of research includes concrete technology, non-destructive testing of RC structures, and repair and rehabilitation of RC structures. So he has published over 100 papers in journals and conferences and 1,500 technical and consultancy reports. So Dr. Balasubramaniam is a rare combination of both academics as well as practical realities. So I think he would be able to throw, and he has thrown a lot of light on various construction problems, various concreting related aspects. So I'm sure that this session would be very useful to all of us. Ramco Cements has been organizing such webinars for the past few days, and we had earlier webinars on blended cement, on risks in civil engineering, and a panel discussion on the impact of COVID on construction industry. And today morning, we had a discussion on smart cities. So tomorrow there is a webinar on high performance concrete, and thereafter we would be having a session on ferro cement the day after, and then modern construction practices. So Ramco Cements as an organization believes in disseminating information through various experts, and we believe that this series of webinars would be useful to all those who log in, and we would be very happy to be in touch with you. Another very important thing that we have taken in the recent past is we have been able to introduce this right product for right application. Rather than just specify one type of cement, we understand the concrete requirements. So that is why we produce ordinary Portland cement 43 grade, 53 grade, Portland Pozzolana cement, Portland slag cement, rapid hardening Portland cement for precast works, sulfate resisting cement. So the concept of right product for right application is what we believe in, and that is what we have been advocating. Now with those words, let me hand over this to Dr. K. Balasubramaniam, who would be talking about concrete quality and site related issues. Over to you, sir.
Yeah, thank you very much, sir. First, I would like to thank Mr. Anil Kumar for this opportunity given to me. And whatever I'm going to speak today will be on basically the site-related issues in the construction industry. And sir, can we start, or we need to wait for some more time? People have logged in, or
they are about I think close to 500 have already logged in, sir.
So I'll just start the.
I think you can start off. Let the others join us.
Yes, sir. Thank you. And the outline of my talk is going to be cracking in concrete, then batching and pumping, superplasticizers, general site-related issues, and lesson learned, and the non-conformities at site, how they are closed. And before that, today what we are finding is we are having a number of durability, a lot of quality issues in the construction industry. Despite having very good materials, very sophisticated structural analysis, all those things have not resulted in durable structures. Sometimes what happens is within 20 years, we are forced to do a lot of rehabilitation, and that is leading to a lot of problems for the owners. And the basic reason could be that we are not very sure how durable our concrete should be. Whether we want our concrete structures to last for 20 years or 1,000 years or whatever thing, or what should be the service life of the structure. Are we really designing for the service life of the structure, or whether the specifications that are being drawn into the particular project, whether they are oriented towards the service life of the structure, what happens today is most of the specifications, we say grade of concrete M25, minimum cement content 320, exposure condition severe, maximum water cement ratio. That's all is given in most of the specifications, and then that creates a lot of issues when the contractor codes. So he assumes certain things and then codes, and then all these things lead to a lot of problems. If things are very clear at the specification stage, then many of the problems what we are facing in the industry, particularly during concreting, will not happen. And whatever I am going to speak for the next, I think, 50 minutes or 55 minutes, it is my experience in the past 10 years, because 25 years I've been only a research scientist. And this past 10 years, whatever, I'm going to a lot of sites, and I just want to share the problems that are there, what I'm seeing, and it is only from my perspective. And, it is not like criticism. I mean, please kindly don't take it as a kind of a criticism or anything, because I know in this 500, 600 gathering, there may be people from RMC, there may be site engineers, there may be professors. I mean, so I'm going to talk it in a very general way. So it is what from my perspective, what my eyes are seeing, what I understood in this part 30 years or 35 years of my professional experience. And if you look at concrete technology, the entire concrete technology boils down to only 4 things: curing, compaction, cover block, and water. You put the correct amount of water, put the proper cover block, then properly compact the concrete and cure the concrete, going to be not much of issues. But unfortunately, we are in an industry where we work with a lot of illiterate bar benders, carpenters, and also we are not like mechanical engineers who can produce 1 millimeter accuracy thing in a factory. So usually we are working with heterogeneous material, and a lot of issues are there in the site, unforeseen. So all these things lead to problems. Mostly, I'm not telling these problems are deliberately made, sometimes out of pressure, because we all work from morning, I think 8 o'clock till night 8 o'clock, Monday to Saturday. Sunday we work from 9 to 2. The huge pressure on the infrastructure engineers, and a lot of fatigue sets in, and then problems do happen. But there are some things which can be avoided. What we are going to talk today is not something very theoretical. Some of the things which could be really avoided if some minimal effort is put in. So I'm going to only focus my talk towards it. So the first one would be the plastic shrinkage cracks. In Tamil Nadu particularly, where I come from, these cracks are called as air cracks, because these cracks go in a random pattern, and they appear within about 30 minutes to 2 hours. And sometimes the cracks are there only on the top. I mean, it generally happens in a deck slab. It is only if the deck slab is 15 centimeter thick or even 20 centimeter thick or whatever, 12.5 centimeter thick. These cracks are sometimes in the top 2 centimeter, or sometimes top 3 centimeter, or sometimes it is through the depth of the slab. And this is basically the soffit of the slab, where you can see the cracks at the bottom and water leaching through, the curing water leaching, the seeping through the thing and then leaching out the calcium hydroxide, that white color patch you can see. And this is another pattern, another side where these plastic shrinkage cracks are there. Now they are, cut a V groove for repair. And the same slab, you can see the bottom. And these cracks happen because for very, very reasons beyond our control. And whenever these cracks happen, before going into the causes, I'll tell you the mentality of the site engineers in the field. Generally, these cracks come, they call it as air crack, and they let it go. And suppose then it is through the thickness of the slab, then it starts leaking, then NCs are created, then people wake up. And if it is only in the top, and if it is not in the bottom, they call it as air crack. And then what they do is they take a cement sand mortar, throw it on top of the slab, then take a broom and then broom it off. And they feel that the broom marks and the crack marks will merge, and the client engineer or the PMC engineer, they may not notice it. But then that is not the right approach to closing these plastic shrinkage cracks, because I'll give you the reasons why these plastic shrinkage cracks happen. It comes because of temperature, humidity, and wind velocity, over which we have no control. We just can't control the temperature, we cannot control the humidity, we cannot control the wind velocity. And the reason is, when we place the concrete, the water starts evaporating. That is very natural. But let the water evaporate, but that is compensated by some water that comes from below. That is called as the bleed water. So water starts evaporating, then that is supplemented by the bleed water. But sometimes due to temperature, humidity, and wind velocity, the rate of evaporation of the water will be much faster than the rate at which the bleed water comes to the surface, and you get cracks. So these cracks, what we have to do is we need to take a wooden float and then take the wooden float and then float it across the cracks and sprinkle with water. It is a very simple process, doesn't happen. And if you were looking about 20 years back also, and particularly this is very rampant when we are using RMC. And the 20 years back also, these cracks were coming. But 20 years back, we were doing concreting at such a slow pace because we are using a tilting type drum mixer. So from one end you start, after about 1 hour or something, it will be only about 5 feet or 6 feet from where we started. So the masons those days, I mean, the cracks they could access, they were seeing the cracks and then they were closing it. Today, in 1 hour, you are starting from one end, we go nearly 10 feet, 12 feet, 15 feet away from the thing. And, we go there, the pipelines go, the engineers go, the site engineers go, and the workers go there, the masons go there. And these cracks appear after 30 minutes. So nobody has the, intention to go and have a look at the crack and then close it. So, and these cracks happen, and then, it becomes an NC, and then if you're a contractor, please don't take it in the wrong sense, because this is what we see. The moment the cracks come, then the NCs are raised, and the contractor immediately puts the blame on the RMC guys. The RMC guys, they don't know what to do because they know that it is the responsibility of the contractor to close the cracks. So, but then they want more and more, jobs from the same contractor. So they just don't know anything. So they don't know what to do. They know that the contractor should have taken a float and floated it, and they don't do it. And then they are now blaming me because NCs have been created. Now, if I start, lecturing and then teaching them, then I may not get more further contract. So they simply go to some agencies and bring a rebound hammer and hit the rebound hammer and get some numbers and say, okay, my concrete is fine. They want to prove like that. So this is not fair. This is not right. So you have a plastic shrinkage crack, then, all you need to do is float. For example, you are going to do, nowadays, the rate at which we are pumping concrete is phenomenal. We are doing 150 cubic meters of concrete from night 10 o'clock to morning 6 o'clock. So 150 cubic meters of concrete at about even 5,000 rupees is about 7.5 lakhs. And the shuttering and the reinforcement maybe another 7.5 lakhs. So the billing for that night is 15 lakhs. So if the billing is 15 lakhs, generally, for so many square meters, they have so many masons, so many assistants. That will not work. They need to have extra 1 mason or 2 masons, depending on the area of the concrete. So those 2 masons should be exclusively given only for closing the plastic shrinkage crack with a wooden float. That is not being done. Even 2 years, my experience with a construction company where we were insisting on the closure of the plastic shrinkage crack, we were telling 15 lakhs billing or 12 lakhs billing. Extra 2 mason is going to cost you only 1,500 rupees, which is nothing. And you have to spend that 1,500 rupees. And not alone spending that 1,500 rupees and putting those 2 extra masons, the engineers have to go and tell them, boss, there is a plastic shrinkage crack, floated, because otherwise a mason may not have the interest, otherwise because he'll be sitting in some corner. So this also I have seen where we have put extra masons, and the masons are somewhere idling, and then the engineers don't go and tell them, so you have to do it here. And there are some sites where I go, I tell them all these things, then they say, sir, we have some practical issues. Like you are telling the plastic shrinkage cracks comes within 30 minutes to 2 hours. In 1.5 hours, we are far away, but the concrete is still not set. So we are not able to put our foot there and go and close it. I tell them, see, I'm not a skillful person like you. You are more skillful. You must find ways and means of closing the crack. So put some wooden planks, walk on top of the wooden planks, close the crack, and then, find a way to, clear the marks, or you do whatever it is. You need to close the cracks. That's it. So this is something, even today, almost every month, we are getting calls to do revo test on a plastic shrinkage slab. I tell them it is a waste. Before I was pleading with them, nowadays I have given up. I tell them, okay, we cannot predict the strength, we will give you the numbers, based on that, the surface hardness, that's all. But still, people are very happy to do it to close the NC. So a simple thing like this, a plastic shrinkage crack, is being dealt like this in the industry. Now, I've seen in many sites where they say they do the concreting in the night, but then there is a lot of wind velocity in the night, particularly when you're doing in the 5th floor or 8th floor. I've seen in such sites also, they'll say, sir, we did it only in the night, there is no temperature. But I tell them, boss, you have wind velocities there. So ultimately, the water is evaporating. The bleed water is not sufficient to supplement that water. So you are getting, the surface becomes very dry. So all you need to do is floating, whether you're doing it in the night or in the morning or in the afternoon. So, and then you will find those guys making a cement mortar and then trying to push it into those cracks. Nothing will go inside. And sometimes what happens is, your plastic shrinkage cracks come, then it leaks, then people get worried, all kinds of things happen. And then what happens is, sometimes the water that is leaking through the cracks, sometimes it leaches the calcium hydroxide. That's why you see a white color patch on the bottom of the slab. And this leaching of the calcium hydroxide sometimes closes the crack by itself. But as a consultant, you have to tell them, so cut a V-groove at the top and close it with the SBR, and then bottom, you grout with the low viscous epoxy resin or grout with the cement with the admixture with the shrinkage compensating compound. That is a normal thing we are telling. But you look at the cause and the reason, it is nothing. With little extra care, with hardly extra 2 masons, again, I'm telling you, depending on how big a surface is, with a 1 mason or 2 mason, you can close this. So this is the first thing which I wanted to talk. That is plastic shrinkage cracks. They happen because of temperature, humidity, and wind velocity. They invariably happen on all the deck slabs, whether you're doing concreting in the morning, afternoon, night. The reason is water evaporates, that is supplemented by the bleed water, but sometimes the rate of evaporation of the water will be much faster than the rate at which the bleed water comes. So surface becomes very dry and you get cracks, and it doesn't have any specific pattern, irregular pattern, what we have seen a few slides back. And all you need to do is take a wooden float, not a steel float, take a small wooden float and then just float it across the crack, it will go away. And if you are going to come after 3 hours, 4 hours, then just floating is just not on. And then sprinkle water, don't pour too much of water, just sprinkle water, that's it. This is the first one I wanted to show you. The second one is plastic settlement crack. This crack will be again on the deck slab. This will follow the pattern of the rebars. Like, you are having rebars in 2 directions. It will just, on the top of the rebar, you will find these cracks in a grid-like pattern. The reason is inadequate cover at the top. So preventing the aggregates from settling down, and you get these cracks. And you go to any textbook, how to avoid, rectify these cracks, they say revibrate. You need to revibrate. Again, you come next day morning and look at these cracks, nothing can be done. So all you need to do is revibrate. So this is a plastic settlement crack. We have about 7 or 8 types of shrinkage cracks. And everything, if the cracks are following some regular pattern, they are structural cracks. Otherwise, it will be mostly cracking, maybe related to concrete. Why we call it as plastic is, it is still in a plastic state, like, it is not set like 30 minutes to 2 hours it comes. So we have seen plastic shrinkage crack, we have plastic settlement crack, and we have drying shrinkage. And drying shrinkage, all the designers are designing for drying shrinkage, 0.0035. So that is there in the code. And then apart from that, we have thermal shrinkage, autogenous shrinkage, carbonation shrinkage, and restraint shrinkage. All these shrinkages are there. So the moment you look at a crack, with experience, you will be able to locate it. And then the idea is not to locate it. The idea is to prevent it. And prevention is very simple. As far as plastic shrinkage cracks are concerned, it is simple, wooden float. Nowadays, it is very disturbing. You go to many sites, they say that they don't have a wooden float. That's very disturbing. Even in very big companies, even in companies which have taught the concept of plastic shrinkage cracks to the entire construction industry in this country. Even such companies, some of the sites you go, they don't have a wooden float. And the boys are asking young engineers, what is a We call it in Tamil, we call it as Manias cutter. I do not know the corresponding Hindi name or other language names. It's a simple wooden float. So that's very disturbing. And then another crack which we keep constantly going today as a consultant is the flooring cracks. What happens is when you do a flooring, we need to cut the grooves within about 24 hours. But invariably, the grooves are not cut within 24 hours. They are cut much, much later, maybe 3 days later or 4 days later, or sometimes even about a week later or a month later. And then on top of that, they have a nice flooring, and then they may do everything they will be doing, vacuum dewatering, floor hardener, and then they do epoxy flooring also. And then suddenly these kinds of cracks come, owners will be very upset. So they spend a huge amount of money, and then these cracks have come, and very unsightly. I mean, nothing. It's not going to cave in and then create problem. Then you spend so much of money, and then you give them this kind of a thing, and these cracks come within the defect liability period of the structure. So the contractors again move in and then do something. Even nowadays, the goodwill what the contractor and the owners they have. So even after the defect liability period, I've seen many people going and trying to do something about it. But then already damage is done. What are you going to do about these cracks? You're just going to give some V-groove cutting and or grouting. I mean, it is just doesn't solve the problem. So the grooves have to be cut within about 24 hours. This is not happening in many sites. So this is I would like to stop this much with the cracking, because another cracking which we are constantly seeing is not structural crack, but a crack at the interface of the beam and the masonry, a crack at the interface of the column and the masonry, because again they don't cut a groove at the interface, and then the coefficient of thermal expansion of masonry and concrete are very different. So naturally, you see a separation crack at the junction of the masonry and the thing, and so they need to cut a groove or put up chicken mesh and do it. Sometimes they do put a chicken mesh, but unfortunately they put the chicken mesh on the inside where the tension comes on the outside. So these things are very simple things, and the site engineers are so skillful. But maybe time constraint, everything is there, and there are a lot of things that are happening, but still, these things can be, looked into. Unnecessarily, why should we, for 15 lakh billing, and, you are not trying, you are trying to put extra 1,500 rupees, extra 2 masons to float it, and the wooden float cost you nothing. And similarly, plastic shrinkage cracks are rampant, plastic settlement cracks are very rare in our industry. But there are a few sites where we have seen plastic settlement cracks also. This is very simple. So this is what I just thought, the first part of the thing. Then now I'll move into the most worrisome thing in the RMC, because RMC is a great thing. I'm not trying here to say that RMC is a great thing that has completely changed the way in which we are doing construction today. Because 150 cubic meters of concrete, 200 cubic meters of concrete will take 2 days, 3 days. We are now able to do it within about 8 hours and then move on. And that is one of the reasons why our infrastructure has grown at such a great pace. So there is nothing wrong with the RMC. Only the specifications create problem as far as RMC is concerned. Because batching and pumping, concrete should be workable at the time of pumping. Everybody knows that workability should be good, and then workability is measured in terms of slump. And slump at the time of pumping, I'm saying at the time of pumping should be 100 to 120 mm. It will be more comfortable if it is around 110, 120 mm. But if it is to be 120 mm or 110 mm at the time of pumping, it should be much higher at the time of production. It should be around 160 or 170 or 180 to collapse, depending on the transit time from the batching plant to the site. So it may vary from site to site. It's very, there is nothing like you have to keep 170, 180 slump or something. So this is something which is creating a lot of issues today in the construction industry. I'll just tell the reasons why that's happening. For example, we started the lecture today at 4 o'clock. So I put that time. Suppose we start the batching at around 4 o'clock. If you're having an M1 plant, it takes minimum 15 minutes for batching. So I'll say 20 minutes. I'm taking don't take these numbers, I just put it for you to have a feel. So by 4:20 p.m., 4:15 p.m., the batching is done, 6 cubic meters of concrete. So the time at which the transit mixer left the site after DC, because there are formalities there, They would like to take a slump at the after the immediately, and then there may be some payment thing. In some cases, the batching plans, and then the DC has to be done, and all that may take about 10 to 15 minutes. 10 minutes. People say, I do the batching like that, it comes out. It doesn't come out like that. So that's 10 minutes gone, and then I'm assuming a very reasonable time of 45 minutes. It may be 30 minutes. If you are having a dedicated batching plan, maybe 10 to 15 minutes. And if it is a commercial plan, then at least it takes about 30 minutes to 45 minutes, sometimes 1 hour, 1.5 hours. We don't know. So I'll just assume a 45 minutes transit time. So 4 o'clock it is batched, 4:15, 4:20 it is over, 4:30 after the DC and other formalities it comes out. So reaches the site at 5:15. Doesn't mean it reaches at 5:15, it will immediately start pumping. Again, they'll come, take a slump, everything. And 5:20 or something, it will start pumping. And if it is a slab, it is 15 minutes, sometimes 10 minutes, 15 minutes, 20 minutes. So 5:45. So what the time is now, 4 p.m. it was started, 5:45 p.m. it is ended. So it is about 1 hour and 45 minutes. So at around 5:30, 5:40, the slump should still be around 110 or 120 mm. Otherwise, your mix workability will be stiff, your slump will be low, and your pump will start choking. So the moment pump starts choking, a small boy who comes along with the transit mixer, because every transit mixer has 500 liters of water. So even or like the pump to choke or the thing to get stuck to the the transit mixer inner side. So you'll add water. But unfortunately, what happens is the moment it comes to the site at 5:15, they'll take the cubes, because only when the cubes pass, the bill passes. So this is something. Again, whoever are there, 500, 600, please don't take it in the wrong thing when I say the bill passes only when the queues passes. But then you go stand there, you will see for yourself. So what is happening? If it is a slab, it is 20 minutes. For example, if it is not a slab, they want to do with the columns also, large columns. Then it will not be 20 minutes. It will be much more. So whether the concrete mix which I have designed, whether it will hold the retention, that is whether it will show the slump of 110 or 120 after 2 hours or 2.5 hours, is something which has to be decided at the time of the specification. So the specification should clearly say, because when the specifications are drawn, you know where you are going to, you know your site, and you know approximately how you are going to do the concrete, whether it's going to be through a dedicated plan or through a regular batching plan. So it should very clearly say the retention time should be a minimum of 2 hours or 2.5 hours or 3 hours. There should be a line, at least a line should be there. So that is not there. So that is letting loose a lot of wrong practices when it comes to RMC, because it's a very tough market today, whether you take a cement market or you take a RMC market, because there is so much of competition. There's so many players. So an RMC guy may lose a job if he is going to quote 50 rupees more. So as a owner, as a PMC, I should be very clear what I want. And I should be evaluating my various proposals or various commercial terms in terms of performance. So that is not happening. People are simply negotiating for price. So with this, I'll go to the next slide. So my idea of projecting this is, when you're pumping the concrete, slump should be something 120 mm minimum, 110 minimum. They'll say 90 mm, but 90 mm is dicey. So 110, 120. If it is to be 110, 120, it should be something much higher at the time of production. How high it should be, we don't know. Like, it depends on the transit time, depends on what kind of a thing you are going to pump, whether it's a slab, whether it's a column, or whether it's something. So you need to be very clear, and those things have to come into the specifications. Okay, at least in a some kind of a way. I'm not telling it's very difficult to put for separate things, but then you need to have something there, so the contractor understands at the time of quoting itself. So these are the things which he is looking at. So why is, I'll just come through the next slides. Okay, this is I hope that this is clear. And next is now you take the code RMC. There is an IS code 4926, and 4926 is only a guideline. It's not like 456, which is a kind of a Bible. And 4926 says concrete should be placed within 2 hours from the time the cement comes into contact with water at the batching plant. But that's only 2 hours is only some kind of a guideline. Sometimes I find there are sites where the transit time itself is 1.5 hours. Batching is 20 minutes. You just can't place it within 2 hours. So, and then now the kind of admixtures which we are using, we are generally using SNO based admixtures or a PC based admixtures. Mostly SNO based admixtures will have 1 hour, 1.5 hours, 2 hours retention. The PC based admixture may have 2.5 hours, 3 hours retention. And now they have the construction chemical companies have come out with the mid-range thing. It's called mid-PC, they call it. So they may be able to hold the retention for 2 hours, 2.5 hours, and each one has a certain water reduction capacity also. So an admixture does two things. One is it retains the workability, through the addition of a retarder, and also it has a certain water reduction capacity. So that's another issue which people don't understand properly, which I want to project. So basically the code says to us, but it's only a guideline. It depends on your site specific thing. It can be even 2.5 hours. It can be even 3 hours. Again, depends on where you are, the transit time. You may be in a very difficult site where you are not put a dedicated batching plant, and you have to depend on a batching plant which is 1.5 hours away. So that time your retention should be minimum 2.5 hours. So these kinds of things are not properly thought of. People think I get a design mix from IIT or from some government engineering college. Okay, I get the quotation and then I give the work order, job is done. No, it's not done. It's just not done. So next one is the admixtures, because RMC is the greatest thing that has happened, and RMC is not there without chemical admixtures. That's one of the greatest thing that has happened, because without chemical admixtures, we can't do concreting now. So one is a Superplasticiser, second is a retarder, third is an accelerator. We don't do much of accelerator in our country. That's only for precast industry. So what we are having is a Superplasticiser, which is water reducing, and the same Superplasticiser contains a retarder also, which prolongs the retention of the workability. So I just want to just deviate a little, and this I don't have to show with Superplasticiser, without Superplasticiser. The very crude example from the RMC, please forgive me, because I have put it with a very crude example, the concept of a Superplasticiser. Suppose you are doing an M25 grade concrete, and all these numbers I have put are only for you to have a feel. These are not, very unique numbers. It can be anything. Generally, for M25 grade concrete, 0.5 water cement ratio is done. If it is a commercial batching plant, they can even put a 0.52. They are confident. Sometimes you are putting a fly ash or slag, it can be even 0.48. But I just, for making you understand the concept of a Superplasticiser, I have taken a water cement ratio of 0.5. Water cement ratio of 0.5 is nothing but water by cement. It can be 200 water, 400 cement, 190 water, 380 cement, 180 water, 360 cement, or 170 water, 340 cement. When I put more water, my slump may be more. If I put 160, it need not be 160, it can be even 140. The slump is higher. As I slowly starts reducing my water, my slump starts reducing. And but then, so it's more comfortable to put 200 water, but then I'm using more cement. So I always want to use less cement because I want to conserve my limestone reserve, as well as I want to reduce the heat of hydration. So I always would like to go as little as possible, but of course, everything depends on the environmental factor. Mild, moderate, severe, very severe, extreme, whether it should satisfy that. That is the bottom line. That should be satisfied. So if I'm going to take a 340 cement, then the water becomes 170. My slump will naturally come down. It will become 80 mm. So I need to put the Superplasticiser to push it to 140, 150, or 160. So these Superplasticizers are basically water reducing admixtures. From 200 water, I'm able to reduce it to something less. So the purpose of the Superplasticizers is, generally people think Superplasticizers are added to increase the workability. Yes, Superplasticizers are used to increase the workability. But the main, the concept is water reduction. You want to reduce the cement, but then we need certain water cement ratio to achieve the strength. So when I reduce my cement, my water starts getting reduced. So when my water starts getting reduced, my slump starts reducing. So to push it up to a certain level, I'm using Superplasticiser, and these Superplasticizers are basically water reducing admixtures. The working of Superplasticiser, okay, we need not go too deep. Basically, these Superplasticizers are some long molecules. So these long molecules are because all the cement particles are together, they are flocculated. So it doesn't separate out. So, the workability becomes very stiff. So it has to separate out. So When we add these superplasticizers, the long molecules in the superplasticizer wrap themselves around the small cement particles and gives it a highly negative electrostatic charge. Positive charge together, negative charge, the cement particles, so long molecules wrap themselves around the cement particle, gives it a highly negative electrostatic charge. So all the cement particles starts deflocculating. When they start deflocculating, the entrapped water is released, workability is increased. Concept is very simple. We don't have to worry much about that. What we need to worry about is something very, very important. Whether you are a site engineer, whether you are a procurement engineer, supply chain person, whether you are a contract person, particularly at the lower levels, you have to understand the different types of superplasticizer. Because I'm not allowed to understand, have some kind of a minimal mastery over it. Otherwise it's finished. Yeah, all kinds of problems happen and everything is swept under the table by passing the cubes. And because we do so much of hard work, we do everything, but then why we need to fudge the cubes? Not at all required. But that is because people are not able to understand the concept of a superplasticizer. So superplasticizers are basically water reducing. So this is fine. Concept, all that is fine. It gives a negative electrostatic charge and then deflocculates. All that is fine. No, the most important is what are the various types of superplasticizers. We have lignosulfate. We don't use modified lignosulfate. We don't much use because the water reduction capacity is less. Melamine, it's only for cold countries because it doesn't hold the retention. What we are basically using is sulfonated naphthalene formaldehyde, which is called SNF, and polycarboxylate ether-based admixture, which is PC. So the water reduction capacity of SNF is 15 to 20%, and the water reduction capacity of a polycarboxylate ether-based admixture is 30 to 35%. The SNF will hold the retention for 1 hour, 1.5 hours, 2 hours. A PC will hold the retention for 2.5 hours, 3 hours. A mid PC will hold the retention for something. So I will try to put it in a small, thing. If you are a construction chemical person or an RMC person, don't get upset with me because I have put it in a very crude way. So what are the different types of admixtures? We have SNF. In the SNF itself, we have weak SNF, strong SNF. In the sense, everything is money. Everything is money. A weak SNF may cost you around, I'm talking of project, infrastructure projects, may cost you around 25 rupees. A strong SNF may cost you somewhere between 35 to 40 rupees. Again, I'm just giving you some indicator now. It can even be 45 rupees. A weak mid PC may be something costing and maybe around 40, 45. A strong mid PC may cost you around 70 rupees, 65 rupees, depending on your volume, everything. And then a PC will cost you around 120 rupees. No, we are not worried about all these things. No, you should more worry about the water reduction capacity and the tentative workability retention capacity of these various things. A weak SNF will work at 170 watt. It may hold the retention for only 60 minutes. It may cost less. And a strong SNF may work at around 160 kg. I mean, again, all these numbers are tentative. Please don't take these numbers per se because everything depends on the formulation of the superplasticizer. Okay, it may, strong SNF may have 160, may work at 160 water, and it may hold the retention for 1.5 hours to 2 hours. Again, may, everything is may. The weak mid PCE may work at 165 kg per meter cube water content. Then when I talk 165, it is free water. And may hold the retention for 1.5 hours to again 2 hours. A strong mid PCE may work at 155 or 160. I don't know. Again, it depends on the formulation. And may hold the retention for 2 hours to 2.5 hours. A PCE will hold the retention for approximately 2.5 hours to 3 hours, and it can work at a water content of about 140 to 150 kg. So, sir, you are there, Mr. Pillai. Sir, you are there, right? Your video went off. Okay, right. So please understand that this is particularly the people at the supply chain should understand this. What is happening today? There is so much of again, like RMC, like a cement. There are so many construction chemical companies, and I mean, I have a lot of respect for all the construction chemical companies. But then when you start negotiating very, very unreasonably, then the formulation goes for a 6-set. So you should know what my design mix is. I'm doing a M30 grade concrete or whatever grade concrete. My water cement ratio is this much. So my cement content is this much. So my water is this much. So I have to choose an admixture which will work at that water. Now my site is here. My batching plant is there. So I know the transit time, and within what time my concrete should be placed. So you ask the construction chemical company guys, sir, this is my water content and this is my retention time. So you suggest an admixture for that. So he will suggest an admixture, but then people start negotiating. So ultimately, things take a backseat. Negotiating comes with only a very strong supply chain management company, huge giant companies. Whereas with small time companies, a lot of ignorance creeps in. You just don't know that they will say minimum cement content is 320, and maybe M30 grade concrete. So water cement ratio should be 0.45. It is simple. There is no great science or no great mathematics. W by C equal to something. So for M30 grade concrete, the water cement ratio should be 0.45 fixed. My cement content from severe exposure condition 320 fixed. So W by 320 equal to 0.45. W equal to 320 into 0.45. No great thing. 144 water. Will 144 water work with an SNF? This rudimentary knowledge is not there, then it goes for a toss. And this is what is happening. Every site, there are fights. So somehow they pass the cubes, and sometimes, the QC fellow, he is pushed into a situation. I am very sympathetic to all the QC boys at the site, because they don't decide the admixture, they don't decide the retention time, they don't do anything, but then they have to pass the cubes. Very unreasonable. Because if the cubes fail, certainly for 2 times, 3 times, that fellow loses his job. So he goes out of the way to pass the cubes. So that's why you will find the moment the transit mixer comes to the site, the QC boys will be running to take the cubes. I'm not trying to generalize it. I'm not trying to find fault. Why cubes are failed? This is the answer. So you take a cube, core, people are very unhappy. People don't want to take cores. They know that despite all this, cube has failed. They know the course will fail. So they bring in a rebound hammer. Rebound hammer always predicts a strength 1.5 times, 2 times. Of course, in this journey, maybe a lot of people may not agree with me. I have no problem. This is my perception of how I am viewing things. There are people who believe in rebound hammer. Rebound hammer always gives 1.5 times, 2 times more strength. You can go and talk to the core concrete technology people. They will tell you it gives you more than 1.5 times, 2 times more strength. So why we need to do this? We are spending so much of money. We are doing everything possible. But then through a poor choice of this admixture, the retention time is not there. I've seen vice president level people coming and fighting it out with me. They'll say, sir, I have a dedicated batching plant. It takes only 15 minutes for me to place the concrete. And then I tell the boss, you're a vice president. Please call the QC guy. I want to know why this has failed. Why are you blaming me that I have tested the course and that have failed because I'm bringing you bad message? Okay, then the QC guy will come. They'll say, yes, a dedicated batching plan, CP30, 20 minutes batching, 5 minutes DC, 25 minutes gone. Within 10 minutes, 15 minutes, it'll be there in the site. So what did you do? Did you do a slab? No, sir, I did a footing. How long it takes? How many cubic meters you batch? 6 cubic meters. Each footing, 2 cubic meters for each footing. Now you have to change the pipeline. One that is 10 minutes gone, changing the pipeline. Another 10 minutes gone, again another 2 cubic meters, another 15 minutes gone, changing the pipeline. All this takes time. And the moment you think you have a dedicated batching plan, can be done like that. It cannot be done like that. If it is a slab, you can do it. If it is something else, you can't do it. So practically, it is very simple. The kind of skill level what our engineers possess is nothing. So they have to look at the reality. They feel that concrete mixing, dumping, that's it done. They take so much of effort, like barbending, formwork, shuttering. So much is happening, and this is a very simple thing. And if you look at the overall cost of the project, 10 rupees difference here or 15 rupees difference in an admixture is going to be a drop in the ocean. That particular 400 crore project, a 500 crore project, even for a 100 crore project, it's going to be just a drop in the ocean. Not happening. I do not know. People have to do a lot of soul searching. Why this is not happening? So if I can carry 20 kilos, I can carry only 20 kilos. You put 20 kilos on me, I'll fall down. Same thing for an admixture. An admixture which will work at 170 water, you are going to give a design mix at 160 water, it will not work. It will be very stiff. They will lead to water addition. So the simple example, you may think that I'm trying to, over project this aspect. I'm not over projecting, because we are looking at huge number of core failures where people are very unhappy, very angry with this, because they feel that core is also not good, core test is also not good. I mean, everybody is can have their own views, but it is much better than a rebound damage test. So if you look at this particular, then the question people need to ask: what is it you are negotiating for? Are you negotiating for price or performance? Yes, negotiate for price, but keep the performance at that same level and then negotiate for price. For example, for a 160 water with the free water design mix, you can't put a weak SNF there, which will work at only 170. What a QC fellow at the down the line level will do? He has to pass the cubes. So people have to take a very clear views on these things. So yeah, you will go to a site. This is a pieces girder. Maybe each girder was around 5 to 10 lakhs of rupees. This is a Chennai project. They did the girder, and then they started stressing. The whole end block came off. They said the natural thing is to put the blame on the designer. Designer wrong. The designer has not done the design, so we pulled the thing. It came off. So the designer happened to be some professor. So he took us there, and the grade of concrete. See, this is the kind of failure we had, and I just put it step by step so you understand it much better. The grade of concrete because it's an NHAA project, a bridge project. The grade of concrete is M50 as per MOT specification. It is plus 13 MPa. 63 MPa should be the target strength. And the cement content there they had used was 450. As per MOT, they could have gone up till 540. But he went for 450 kg per meter cube. So, and the water cement ratio was perfect. 0.31 to achieve a target strength of 63 MPa. It was okay. No problem. So now you look at the W by C concept. W by 450 equal to 0.31. W equal to 450 into 0.31, 140 kg per meter cube. From whatever I have spoken, 140 kg per meter cube, they should have gone for a PC. Because the water reduction is very high. So they should have gone for it with a dedicated batching plant, very close by. And 140 kg per meter cube is what they had used, but unfortunately, they informed that they used standard SNF. Standard SNF will have a 15 to 20% reduction. Now, casting at the PSC girder, they should have gone for a PC with 30% water reduction because 140 was the water. However, water reducing admixture of 15 to 20% was used. So naturally, water has been added. Strength has come down. So to reduce workability, so they would have added water. How they will add water is they'll adjust in the total water, free water concept. They'll say moisture, this, that. They'll do something, and then they increase the thing. Higher water cement ratio, consequent reduction in the strength, reduce strength. So you pull it, it comes up. I tell them, boss, you do this kind of fudging in reinforced concrete. I'm not telling do it. You can get away with it, but in pre-stressed concrete, you just can't get away with it. This is not the one site we have seen. 3 or 4 sites we have seen in this past 1 year where the end block coming up. Finally, they took the core. The core came about 25 MPa or 28 MPa. The strength was 50 MPa. If they took the core only after about 28 days. If it is about stressing, if it is M50, 80% pre-stressing, at 7 days. Okay, 40 MPa. The strength should have been 40 MPa. Even after 28 days, the core result showed only about 25 MPa, which means at 7 days there would have been about 20 MPa. Naturally, the end block will come. See, this example I put it only to make you understand that the selection of the admixture plays a very, very huge role in the success of the service life of the structure. You can pass the cubes, but then somebody is paying money. They are putting a lot of faith in you. And they're paying money. So what is the point for a 10 rupees, 20 rupees difference in per kg thing? Why are we doing it? And the project manager was so unhappy with me, and he came and fought. He said, I have done work in Dubai, I've done here, I've done there, I've done so much of precast. And I told him, sir, your end block is coming off. Why are you putting the blame on the designer? Now your own course have shown this result. You please, do so that, you have to change. So people think that concrete is very simple. Yes, concrete is very simple. So whatever I told you, you know the water reduction capacity, workability retention capacity, and call 3-4 guys and negotiating at that same performance level. You start negotiating. You are not going to end up on the wrong side. So this is something which I wanted to more focus. So again, another issue is moisture correction. And Mr. Pillai initially came out with a question. Somebody asked, why the lab, there are some issues. Many of the engineering colleges, unfortunately, they don't have the total water, free water concept. What they do is they put some cement, and then suppose the water cement ratio is 0.5 or something. For example, you see in many sites in Chennai, they will do the RMC for beams and slabs. Columns are generally done with the tilting type mixer machine in the thing. And most of the sites will not have a oven. How will you find the moisture? Your sand, which comes from the river, if it is river sand or M sand, wash sand, has moisture. So the moisture content has to be found out. So in Chennai, where I was really surprised in the month of November and December, many of the cubes will start failing in sites which have, which do the column concrete only with a tilting type mixer, because they don't have a proper thing. What they do is they put 50 kilos of cement and then tuck, 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 they keep adding water. So the water will be sometimes 28 liters, 30 liters, because there is no admixture. They don't use much of admixtures in a small project like 60 crore, 70 crore, 100 crore project. They don't generally use. I mean, please, whatever I'm telling, please don't generalize. You're using, very happy. You're not using, then it's a problem. So the same design which you're using, the same RMC design which you're using, and then using it, then RMC will have an admixture. Here you will not have an admixture. You make some boxes, convert it into volume, and then don't add the admixture. So this free water, total water concept and moisture correction is very important. And that is not done because moisture correction is not an issue in most of the engineering colleges because everything is stored inside. But they don't do the free water absorption in the co-segregate absorption in the sand. So many places where we go as an examiner for MTech or BTech, and again telling not everywhere. Many cases we are seeing simply they will put FCK plus 1.65 into 5. If it is 25 plus 1.65 into 5, they'll put some 33, 34, close the issue. But you go look at the design mix, it's finished. It will not correspond to that. So point out, people are getting asked. So that is another thing which I wanted to share. And other site-related issues, age of cement. Today, age of cement is not an issue because in many batching plants, one side the screw through this thing, your bulker will be doing, and the other side concrete will be going on. So there are sites where they use bags. It's way off sites. At that time, you need to be very careful because you can't use a cement which is more than 4-5 months because whatever certain time we can't store the cement the way IS wants us to store. So moisture will get in, it will hydrate. Use an hydrated cement, it will give you 3-4 MPa less. So you need to be careful. And then cubes, you have to be very careful with the cubes because cubes pass only bill passes. On many sites I've seen when they are demolding the cubes, they unloosen the screw on the opposite side, ulta fire and hammer it on the ground. It just gets broken. 20-25 MPa it will pass. 30-35 and all, sometimes cubes fail, even though everything has been done correctly. Edges are broken. Vibration. Generally, we do vibration to remove the entrapped air because every 1% of the entrapped air removed increases the strength of the concrete by 5%. So basically, everybody knows we are doing vibration to remove the entrapped air and the voids. But if you go to the site, you're going to stand on top of a slab. Okay, then you will find that vibration is being used for a very different purpose. What they will do is, people are sometimes lazy to add the pipe or disconnect the pipes. So they give tuck, 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 tuck. There will be about 20 chokes. There's a huge mountain of concrete that comes up, and they will not use a shovel. They use a vibrator and vibrate it. They'll use a vibrator to push the concrete. So one side you will see water flowing that side, and this side you will find that aggregates are segregating. I've seen with my eyes. Many people done about 300 odd programs, but those are all classroom thing. You ask them, they say yes, sir, it's done in my site. So vibration is basically for removing the entrapped air, but it's not for pushing the concrete. So either you add additional pipeline, you want to go a little, and then don't be so lazy because you're working hard again and again. Underline, you work so hard to achieve something, but then you want to compromise on very silly things, and so there is basically lazy thing, or they want to complete the project before that particular time, shift time or something. So they hit the chokes. and then a huge mound is, I've seen in many sites. And at the same time, you will find when a slab beam concrete is going on, slab concrete will go very peacefully. The moment it comes to the beam, because the condition of the reinforcement, the young boy will come to the edge, he'll whistle and then give a thumbs down sign, which means water should be added. So these things happen. You can just go stand in one corner and watch all this. Why? We should not do this. It's not for fun, like, not doing. It's very painful. And I'll skip all these. BOQ technical specifications have to be read properly, and site drawings have to be read properly. I've seen in a few sites where Q fails and they break the column. Sometimes they go and break the wrong column because they are not read the site drawing properly. And technical specification, particularly this for youngsters, you have to read the technical specification because you may be given a farm work job or a quality job or some job. But then technical, because ultimately one day you're going to become a project manager. That time you need to negotiate with a number of people. If you're not knowing the specifications, then you will find it very difficult to negotiate. For example, a floor hardener, 3 kgs. Sometimes some guy will come and say 7 kgs to boost the sale. You put 7 kgs, the whole floor will come up. Like that, there are so many things because it's very difficult to say that. Other site-related issues, illogical results. Illogical results is something which I have found in many sites because I myself have been the subject of ragging because my boys will go and give 7-day 29 33 MPa, 28 days 29 MPa. So the PMC will take you to cleaners. They'll say how this can happen. The problem is not that they are not looking at the result and submitting. And I'll give you a very practical example where I can tell the site also there's nothing. For an airport project at Kerala, the contractor gave the thing to an engineering college for steel rebar. He tested it. It became only 385. It's in a 415 bar. Professor also did not, maybe he signed it. And then generally, when a bill has to be passed, they'll say mandatory test results are to be submitted. Mandatory test results are not submitted, bill will not be passed. So then the manager will, PM will wake up and say, where are the mandatory test results? That time only they'll wake up. And then, they'll simply, without seeing, they'll go and submit it. There they submitted, the QC fellow submitted to the planning fellow submitted to the client did not see it, he filed it, CVC came and gave them hell. He said 385, 415 should be there, what are you going to do? Then at least, here was a case where, it was a footing where, okay, 385, 415, there is an engineering solution, load carrying capacity has been increased, I'll put shear connectors, I'll put additional bars and I'll do jacketing. I can get it back. But in many training programs where I go, I ask the QC boys who are submitting these, doing water tests, what is the threshold value of chlorides in water for concreting? Nobody will tell me 500 milligrams per liter. Very rarely people tell me 500 milligrams per liter. I ask them how you are submitting the results. Suppose instead of 380, I myself do water tests. Suppose my boys are type 1380, I also blindly sign. It goes to the client and it is a government client. Then can you suck out the chlorides? There's no engineering solution at all. I have found in many sites where my partner is going and repairing, they have put chloride infested water in a 10-story building. It's already started corroding within 2-3 years. So where is the solution? Okay, he is giving some solution, but then the owners have sunk in 1.5 crores or 1 crore for each of their apartment, and then they are stuck with the structure which is chloride infested. So because the reason is that nobody understands 500 milligrams per liter is a threshold value, they just can't compromise on that because there is no engineering solution to remove the chloride, suck out the chlorides. And reading a batch sheet, nobody reads a batch sheet. In many sites, the batch sheets come bundled together on a Saturday because only in a batch sheet you will see, because in the same site, with the big site, it can be an M30 grade or M40 grade. Looking at the concrete, nobody can say it's M30 or M40. DCs are written by hand, very dangerous. So batch sheet is better because it is computer generated, and you read a batch sheet, then it will say the concrete batching started at 4 p.m. Now the retention time of the workability is 1.5 hours or 2 hours. So I should place the concrete before 6 p.m. Without reading a batch sheet, how will you know? Everybody files DCs. This is again very rampant. Yeah, sometimes they give the batch sheets. Many batching plants give the batch sheets, but nobody reads it. So that is another thing. Sudden drop in the slump. I find my practical experiences. I find that sudden drop in the slum, site blames cement RMC guy blames the cement guy will blame the admixture fellow. Ultimately, you will find that there is more silt in the sand that is creating a drop in the slum. So, they need to do inside, investigation without blaming, because once the sudden drop in the slum is there, they will stop the work for 1 week. So, unnecessary problems are there. I mean, this happens in many sites. And the design mix from external agencies, you have to be very, very, very careful. You are getting a design mix from an external agency, you have to do a trial mix. If the trial mix is not good, immediately bring it to that, because design mixes from external agencies, if it is engineering college, you need to be doubly careful. I mean, not belittling them, because engineering colleges, they are not very familiar with concrete pumps, batching and pumping. So they will simply look at 10-62 and give a design. Retention of the workability, they may not check. Simply, I find in many things they say slump is 100 mm. Slump is 100 mm what? After immediately after production, after 1 hour, what will happen to that? Are they checking the retention of the slump? So you should check it 0, 30 minutes, 60 minutes, 90 minutes, 2 hours. I mean, based on your requirement, and then only approve the design mix. I have seen in many places where the consultant gives a design mix, and my God, not pumpable at all. You just can't go and talk to them. It is very dangerous. I have all the respect for the architects and all the respect for the structural consultants, but please stick to your job. Please don't enter into a domain where you don't have much knowledge. I may have a PhD in structural engineering, but today they come and ask me, because my core area is very different. They come and ask me to do design. I'll fold my hands and then walk out. I don't know something, please. I'll say don't know and go. I request that kind of a thing should come to all the people. If you don't know something, please say I don't know and then move on. There is nothing for us to prove that we are great. And that is creating a mess. There are consultants with whom I just don't know, with 35% sand, they want you to pump a pile concrete. Go and plead with them. They will not listen. So again, please, architects and structure, I have all the due respects. But then the core competency is something that should be respected, and people should work as a team. That is more important. For example, if I had to give a repair material, I consult my partner, because I know he's far great in choosing a proper repair material. I cannot, even though I worked with him, I know everything. I don't want to do it. I want my client to get the best. So people have to understand that the core competent people should and then we need to work as a team. And this is not happening. This is not at all happening. So I just will summarize. Lessons learned: retention of the workability, a parameter not given due consideration. Redosing of the admixture on site is not allowed. Very unfortunate, because IS is dealing with different kinds of contractors. So they say redosing of the admixture is not permitted on site. You have to understand 6 cubic meters of concrete. The workability is drops down after 4 cubic meters, 2 cubic meters. No RMC fellow will go and throw it on the dump. I mean, he's not going to throw it on the dustbin. It is anyway going to be recycled. So proper thing has to be done. Sometimes I find that the RMC and contractors are fighting over the yield of the concrete, because RMC may get one source, second source, third source, where the specific gravity may vary. So that may lead to yield issues. Moisture correction should be carried out from the bin, not from the heap, for low water content mixes. There are examples I can give, but time is not there. And sequence of mixing when silica fume and PC-based admixtures are used. When you are using a polycarboxylate with ether-based admixture, you must allow little longer, mixing time. That is very important. Then only you will get the, effect, proper performance. Silica fume, I'll just leave it, because it's a story. Like cement is 290 blains, silica fume is 20,000 blains. So every silica fume particle has got thousands of particles inside. It comes in a densified form. I've seen in many engineering colleges, they dump the aggregate, cement, silica fume, immediately add water. Silica fume will not work. So you have to dry mix it. The silica fume, sand, aggregate, and cement have to be dry mixed, so that the silica fume particles upgrade against aggregate, break down into smaller pieces. Then only they'll have a better performance. So that they have to be careful. I'll just leave this. And this is another cracking which has become very normal. This happens normally in retaining walls, when the retaining wall is constructed for a longer lengths. So this is called a restraint shrinkage crack, a book by Dr. Devadas Menon of IIT Madras, Reinforced Concrete. He only deals with that. At least he's given some equation for this. And restraint shrinkage cracks particularly happen in retaining walls. And the crack will be a vertical crack for the entire thickness of the, the thickness of the wall and at regular intervals. So this people need to be careful because most of the designers consider drying shrinkage. They're not considering restraint shrinkage because it's not given in a code of practice. But practically, even the 2 days back, there was a engineer who was talking about because his site has restraint shrinkage cracks and they are clueless why these cracks came. So the restraint shrinkage cracks is something you can Google and then see, because it happens only in retaining walls which are anchored into the raft. So I'll just conclude because I consumed about an hour. These are things which I have taken from the website. The fundamental things to learn are the principles on which the concrete technology is based. And we must avoid errors of the past in which students were taught already outdated factual information and went forth to inhibit future development, because every day is a learning process. Every day I learn, like, everybody learns, and that should not stop. The moment I have a PhD or something, I feel that I'm done. My knowledge has reached its extreme level. No, whatever you have learned is hardly 5% or 10%. Less than that, 5% is arrogance. So there is a lot to learn, and then every site you go, you get a different crack. If you have already encountered it, you will be able to give a solution. If you're not encountered, either you need to come back, read, or you have to ask somebody who is more experienced than you. That has to happen. But it's not possible for any individual to know even 10% of the available knowledge on concrete. They say, I know 2%, 3%, that itself is arrogance. But it is possible to learn how to function as a forward-looking, receptive, contributing member of the concrete fraternity. And something which, again, I took from the web, which I found very, very sensible, need for flexibility. You cannot teach ability to invent, but not stand in the day. Because things have come from, Superplasticiser came from chemical people. A lot of things are happening, and concrete technology should be open to ideas. And significance for education, practitioners as well as students should learn how to keep up to date. Continued professional development is a huge requirement. And another issue is, unless, like in US, if you look at particularly a doctor who's an American-born doctor, every 10 years he has to take an exam. Here I get a BE, I get an ME, I get a PhD, I'm done, finished. That's there for me. And that is. I mean, I'm not trying to say the change in the system, at least change in the attitude of the people. They need to update themselves. If I don't know how to specify concrete, I should not specify. If I don't know how to do a proper design, I should not comment on it, even though I may have some degrees to boot. It's a waste. So qualification in structural design is an inadequate basis for specification and control. And ill-informed specifiers have held back progress for decades. There should be this is something. This is not going to happen. There will be a legal requirement for an appropriate qualification before being allowed to specify or control concrete. And I only request architects and structural consultants, please, not because I'm a concrete technologist, I'm pleading for it. Please consult somebody when you are drawing specifications, particularly in concrete or in waterproofing or in areas where you don't have much of experience, where other people may have a slight edge over it. And whatever I have spoken is my perspective. I'm not telling whatever I have spoken is right. This is from my angle I have spoken. Some of them you can accept, some of them you can definitely differ. For example, rebound is something which should not be used to predict the strength. That is being done in a very large scale to close the NCs. Closure of NCs, yes, it is a must. But then you need to be little ethical in the closure of the NCs. And whatever I have spoken about plastic shrinkage crack, batching and pumping, it's not something very great. Like, if people apply little of them, because they are literally, to me, the site engineers are really shakers and movers. They are moving huge projects, 1,000 crore, 2,000, 5,000 crore projects. Nothing, absolutely nothing. So if they don't know, they can consult with people who know. So the ego should be, buried. If you really are looking at the service structure and I'm a client who has put so much of faith in you and you want to deliver. So this should be the right approach, teamwork. Okay, thank you very much.
Thank you so much, sir. The presentation was very good. In fact, you have brought in a lot of practical perspectives, which was much more interesting, and many of the construction professionals who logged in have appreciated you for that. A couple of questions, if you would be interested to take, sir, would it be okay?
If I know, I will answer. If I don't know, I need to go back and refer and tell you. Okay. You can ask.
Yeah, this is a problem relating to slump retention. In fact, we also, as an organization, when we interact with RMC professionals, we have also seen this. In terms of slump retention that you have rightly pointed out, 1 hour, 2 hour, 3 hours. Now, there are some RMCs in certain places, like say, for example, in Bangalore, there is a slump retention of greater than 3 hours as well. That is one thing. So what is your views on that? Should it be encouraged, or is it all right to have a slump retention greater than 3 hours?
Sir, you can have it 3 hours. Suppose, see, for example, I'll tell you, I don't want to name the place. A doctor was constructing an hospital where the transit time was more than 2 hours with a few tolls, because because he's a doctor. He doesn't know engineering. And all the queues failed with 8 MPA and 9 MPA. In that case, all the codes failed, 8 MPA and 9 MPA. So there it would be more appropriate to go for an admixture which will hold the retention of 3 hours. It should be specific. There is no generality, to that. Suppose an admixture person is doing an admixture with 3 hours, more than 3 hours retention. Formulation is very, very, important. It is going to cost money. So if your site is that far, then 3 hours retention is required. He has to go for the 3 hours retention or 3.5 hours retention. So that's a must. There is no hard and fast rule in that. Because if you look at 4926, it says place concrete within 2 hours. Is it possible to place concrete within 2 hours? Not possible. I've seen in many sites where the RMC transit mixer dumps about 4 cubic meters of concrete on the ground and then goes. These guys are, taking it in a wheelbarrow and putting. How will they be able to do it within that specified time? It takes 4 hours, 5 hours. It's not done. So 3 hours, more than 3 hours, there's nothing wrong. So long as it doesn't affect the setting time of concrete and doesn't improve the strength, it's fine.
In fact, this is a very valid thing, because we have seen this kind of things happening. In some of the sites, when there is a very low water cement ratio and high compressive strength concrete mixers, there is always this observation that some of them have seen the stickiness in concrete mixers, which can sometimes make it difficult for pumping. This is one problem that one of our participants has faced. So, any suggestions to overcome the stickiness of concrete mixer?
Yes, sir. You have to sit with the admixture guy, formulation guy, and sort it out. See, there was a time, I don't want to name the company, where I was so familiar with that company's all the products. So without even discussing with them, I was able to give the product for that water capability retention and for that water reduction. See, today it's becoming a very competitive world. Now, it is nowadays what I do is I don't want to elaborate on this. Now, if my client wants me to use a company, I ring up the A companies because I know all the formulators. I tell them, sir, this is my water reduction capacity. This is my water content, free water content. This is my workability retention time. So you suggest a good admixture. That saves a lot of trials for me. So
in fact,
that's a very more direct and open approach. And we can't go into the commercial aspects because it is a client who wants an A company.
In fact, we have seen such kind of problems. Even during your presentation, you were talking about the various types of admixtures and cement. At our Ramco Research Development Center also, we have been helping the professionals to do a kind of mixes, which can suit their requirement. But one most important point that you have made here is that even if the mix design is coming from an outside this thing, the trials need to be done at the site so that any variation in the local material or anything is taken care of there itself. Yes. I think that is one important point that you have made.
Yeah, and before you submit to the owner, which is a government organization, particularly in case it's a government, do the trials. Then go back to the professor and tell him you are explaining. The professor will definitely understand your thing and then redo it and then give it. If it is sticky, tell the guy it is sticky. So you call the admission guy, this is sticky, you do a reformulation. If he is not able to do it, go to B company.
True.
It's a one way also. Sir, we can't decide things because formulation is directly connected with pricing. So you are going to hang on to pricing. What he will also do, because the construction chemical companies are not NGO organizations. They are also there for profits. Everybody is there for profits. So that's why I said negotiate for price. I'm not telling no. But when you negotiate for price, look at performance also.
Very true. That's a very good point. And another question which has come about is M50 grade of concrete. How come 450 kg of cement is being used is one of the questions that has been asked.
Sir, M50, again, I'll tell you the real problem. I didn't want to elaborate because it is an NHAA project. It comes under MACE specification. 540 kg per meter cube is a allowable cement content. Now the contractor very cleverly put it as 450 to save the cement. Because of that, the water content came down to 140, and instead, at least he could have gone for a PCE. He didn't go for a PCE.
That's a mistake.
Yes, because here the target strength was 63 for an M50 grade concrete for Chennai airport project. Also, we had gone with only 450 cement, but 3.36 water cement ratio, because there it was 50 plus 1.65 into 5. So 0.36 is more than enough, but here was the target strength was 0.31. I mean 63 MPa, which is 0.31. Naturally, he had to go for that. He could have gone for silica fume. He could have gone for anything, but he didn't go. I mean, you can't go too deep into the the company's thing. It is wrong, completely wrong.
And they're very.
You have gone for a more cement content and push the water up. And one more thing, sir, more cement, more strength is a wrong concept.
Yeah, true. Very true. That's it.
You put more cement, more water, you get the same strength.
One very important question that has been asked with reference to the season. In summer season, there has been observed that there is a sudden drop in the slump, especially in our ready-mix concrete and all that. So is it related to concrete temperature as well as the atmospheric temperature is the question that is being asked.
Yeah, because in summer, your concrete temperature will be about 36 to 37 degrees, because as per hot weather concreting code, the temperature of the concrete should be less than 40 degrees. We always should place the concrete within 40 degrees. But generally, if you put a thermometer itself in your concrete in May month in Chennai, it will be around 36 to 37. 36, 38, again 35, we don't know. Like, it will be very high. So definitely, that will, cause a lot of reduction. So that time, they may have to put, if they are putting 0.8% dosage, they may have to go a little higher.
And also observe that temperature, yeah, 37, 38.
Also, they should pre-wet the aggregates, because most of the time the sprinkler system doesn't work. Because the aggregate should be pre-wetted. Most of the batching plants, it doesn't happen. They have a sprinkler system. Some of them don't have a sprinkler system. Some people are doing it. Some people are not doing it. They have to pre-wet it.
I think one more question was, one question was related to your example. I think you have already, please don't take the numbers very seriously, but then he has taken the numbers and he has asked why in some cases when the 7-day strength is 29 MPa, how come the 28-day strength is 28 MPa? Is it possible or what is it?
Sir, it is not possible, sir. It is all a mistake. That's why I said illogical results.
Illogical results.
Sometimes typing, these guys may make a mistake also. That's what I said. Instead, if I give a 320K, what is it called, chloride content, milligrams per liter. Suppose I type it as 1320, it is nothing. It is a mistake. It is an error.
Okay, one more. I think 2 questions more before we close the session.
Yeah, sure.
Is there a possibility of development of shrinkage cracks when superplasticizers are being used? One question.
The superplasticizers or cement or anything has got nothing to do with plastic shrinkage. Plastic shrinkage happens because of temperature, humidity, wind velocity. Suppose you put fibers, it may sometimes control it, but fibers are quite expensive. And sometimes they're putting these polypropylene fibers. Polypropylene fibers, the problem is it may choke the pump sometimes. And they may have some marginal effect. I will say only a very marginal effect on the shrinkage. Shrinkage cracks, take a manias cutter or the wooden float and float it. Put extra 2 mason. That is the only solution for it. Don't please waste money, too much of money on all these things. Extra put 2 mason and close the issue.
Heat of hydration of cement, does it have a play on the shrinkage cracks?
Yeah, may have, but the heat of hydration, the problem will come with the temperature, because when I say in summer, the temperature of the concrete is around 36 degrees. I mean, temperature of the concrete, when it goes inside and starts hydrating, it may move to 75, 80 degrees. So that may create some micro cracks, internal micro cracks when the temperature gradient is more than 20 degrees. That's the only issue. Shrinkage, yes, maybe. I don't know. I'm not very sure about it. But see, let shrinkage cracks come. What I'm telling is shrinkage cracks will come. Please don't blame the RMC people for that. Take a float and float it and close it. Put extra labor and look out for it. If you are not going to look out for it, then it'll stay.
So one last question, sir.
Yes, sir.
Yeah, one last question is, this is very difficult to answer, I believe, because it depends from site to site. The question is, what is the percentage variation that is allowed for a trial and actual cube strength result? Or I think what he meant was that
very easy to answer, sir, because any trial done at the lab should be FCK plus 1.65 into 5. Suppose I'm designing for 30 MPa, for FCK 30 MPa. In the lab, it should be 30 plus 1.65 into 5. So which is coming somewhere around 37 or something. But in the field, there is an acceptance criteria that is given in IS 456. Any 3 consecutive samples should be FCK plus 4. No individual sample shall be less than FCK minus 4, 3 or something. It is there. So it is
acceptance criteria is there. Yeah.
Yes, acceptance criteria is there. But in the lab, in the trials, what you are doing with the pan mixer, a small pan mixer, it should always be FCK plus 1.65 into 5. That's it. And in the site, it is acceptance criteria as per IS 456. Plus 3 minus 3. That is FCK plus, in 3 samples, the average should be that much, and no individual sample shall be less than FCK minus.
So thank you so much, sir, for your inputs. I think what you have made the point is it's a holistic approach towards concrete. You have the practices, the quality of materials, the way we look at it, IS code guidelines, practical aspects. It all changes from site to site, and we need to apply our mind to that. And very good point that you have made is that learning is a continuous process, and we need to learn, and we should not be confined to our degrees or qualifications, and we should continuously upgrade our knowledge. A very important message that you have given. Thanks for that. And I am sure the attendees today would have taken a lot of things from this session. So thank you, sir, and good day. And for the next webinar, we would be meeting tomorrow at 4 p.m. on high performance concrete by Dr. Nagendra. With those few words, I thank you, sir, for having accepted our invitation.
Yeah, thank you so much.
Thanks all the attendees for having joined us. All the best. Thank you.
Thank you, sir. So I can move out, sir. I can close it.
Yeah, please.
Thanks.